Unit 3, Scatter Plots and Bivariates. We're continuing on. Today's predictions, residuals, and goodness of fit. The beginning of class, before you do the notes, you were assigned to do these two ed puzzles. They should help you understand the information in today's lesson. The objective is the students will be able to create residual plots and analyze for goodness of fit. But what are residuals? The residuals are the difference between the observed and predicted values. It measures the distance from the regression line, vertical distance, from the regression line, which would be the predicted value, and the actual observed values. So on the graph at the left, all those points are the actual data. The lines show you the distance from that actual data point to our linear regression equation, which is where we would get predicted values. Notice the far left point is below that linear regression line. So that has a negative residual. We would predict, if we put in the x value for that, a higher value. It would be the value where that vertical line from the point meets up with the linear regression equation. In other words, it helps us measure error, or how well our regression line fits. There's an example of a residual scatter plot on the right that does not match up with the graph on the left. So don't try to analyze back and forth. The dots that are below are negative residuals. They are below the regression line. The ones that are above would have a positive residual, and they would be found above the linear regression line. Notice they are pretty scattered. There are more dots above than below, but we can't see a clear pattern. Observations, predictions, and residuals. To demonstrate how to interpret residuals, we'll use a lemonade stand data set where each row was a day of temperature and revenue. And the revenue is rounded to the nearest dollar. The table is incomplete. Notice that row that says etc. So we're going to be giving you the linear regression equation that we are going to use to make predictions and find residuals. This is the linear regression equation. We get the predicted revenue. It's equal to 2.7 times the temperature. And in this case, temperature is actually in Celsius. And then subtract 35. That is our prediction equation, our linear regression equation. They are giving us that. We cannot get that from the data we have because our data set is incomplete. So let's say one day that at the lemonade stand it was 30.7 degrees Celsius and revenue is $50. We will add that to our table. The $50 is the observed or actual output, the value that actually happened. Let's find the predicted value for that temperature. We're going to use a linear regression to find that predicted value when the temperature is 30.7 degrees. So here's that equation again. Revenue is equal to 2.7 times the temperature in Celsius minus 35. And we are going to plug in the temperature of 30.7. When we calculate, all the values in the table are rounded to the nearest dollar. So we need to round to the nearest dollar, which is $48. that was the predicted value based on our linear regression equation. So the predicted value is 48, but the actual value is $50. So what is a residual? A residual equals observed minus predicted. So the predicted value was 48, the actual value was 50. So the residual is observed, which was 50, minus the predicted, which was 48. So we're going to have a positive residual of 2. Let's see if we can find the residuals for other data points for that lemonade stand data. Here's our equation once again, and we're going to put the X value into there to get our predicted revenue, which is going to be column 3. So when we plug in the 28.2, we actually get $41 as the predicted revenue. If we subtract observed minus predicted, we get 3, because the observed was 3 more than the predicted value. Plug in the next X, the 21.4, and we get 23. That's the same as the observed value, so our residual would be 0. Plug in the 32.9, we get 54, which is much higher than the observed value. So observed minus predicted would be negative 11. Put in the 24.0, we get $30, which once again is just like the observed value, so the residual would be 0, and we did this on the last slide. Residual plots help us to determine if a linear regression line is a good fit for a data set. These are things we need to look for. Do the residuals exhibit a clear pattern? In a good residual plot, the residuals exhibit no clear pattern. In a bad residual plot, the residuals exhibit some type of pattern, such as a curve or a wave. This is an indication that the regression model we used does not provide an appropriate fit to the data. Another thing to look at, do the residuals increase or decrease in variance, the distance from the 0 horizontal line in the residual plot? In a systematic way, in a good residual plot, the residuals are randomly scattered about 0. No systematic increase or decrease in variance. They're spread. In a bad residual plot, variance of the residuals increase or decrease in a systematic way. If a residual plot is deemed good, then it means we can trust the results of the regression model, and it's safe to interpret the coefficients in the model. So we can use that linear regression line to make predictions. If a residual plot is deemed bad, then it means the results of the model are untrustworthy, and we need to fit a different regression model to the data. Here's an example of a good residual plot. All the data points are scattered above and below the line where it's 0. So we have negative residuals, positive residuals, no pattern. That's a good example. Here's a bad one. Look at, there's definitely a pattern to the residuals. We start out negative, do a bunch that are positive, and then go negative again. That's a curve. So that is an example of a bad residual plot. It means if we did linear regression and we get these residuals, linear regression is not a good fit for the data that we originally used to make a linear regression model. Here's another bad one. In this case, the variances keep increasing. And that was one of the things they said was not a good example. So bad residual. So let's select the best statement for this residual plot. Look at the residual plot. I think you'll see it again in the quizzes. We have to determine if this residual plot represents a linear fit, this residual plot represents a nonlinear fit, or the residual plot represents no fit. And it does show a linear fit. There's no pattern, and the distances from that horizontal line of 0 are basically the same, and it's scattered. Here's another one. What are residuals? We said it earlier in the notes. Option 1, possible models not explored by the researcher. Variation in the response variable that's explained by the model. That's actually R squared. The difference between the observed response and the values predicted by the model. That's our answer. Data collected from individuals that's not consistent with the rest of the group. No. How do we calculate residual? We also said this in our notes. It's the observed minus predicted. The two words are in alphabetical order, if that helps you out. You're going to be doing a Google form. I give you a data set. I also gave you a half sheet of paper that has this data. Look at the Google form while you are working through this. This will help you record your predicted values, which will indeed help you calculate your residuals. So please work carefully, follow directions. The predicted values come from the linear regression equation where you're rounding to 3 decimal places. The actual predicted values you're putting in the table will be rounded to 2 decimal places. So there's the 2 Edpuzzles we already did, and that is the Google Form classroom activity. Do a nice job.